I received the clock movement today that goes to this grandfather clock. Because of its size, only the movement was shipped. It has a matching floral design on the pendulum bob, dial, and weights. The weights are common to Dufa clocks of the early 1900s. Movement design is common to Dufa movements. No trademark can be found on this movement, so not 100% sure at this time if it is a Dufa. The center wheel arbor is severely bent. I'll attempt to straighten it. If all else fails, a new arbor will be fabricated. Parts are not easily acquired for these movements. This movement doesn't use a click and ratchet system for winding the weights. It has a silent system that incorporates torsion springs for the winding of the weights. Both torsion springs are broke. New springs will need to be custom fabricated if this clock is ever to work again. This spring has been butchered in a failed attempt to get it to work again. The movement has very thick plates and show no signs of wear to the pivots. The owner is going to clean and lubricate as needed after the repair is completed. Very little to no wear on this movement. An adjustable bushing, used to adjust the thrust tolerance of the arbor that rests in it. Oil can be seen that has run down the plates next to some of the pivots. And here's some random oil sitting on the surface of the plates. Only identifying marks on the movement are the numbers 59879. No trademark stamp can be seen on the movement or case. Not sure if the center arbor can be saved or not. If the steel used in the arbor is malleable, shouldn't be a problem straightening it. I see a carpenter's nail has been used to pin this butchered torsion spring. This torsion spring broke here at the base of the spring. It's a common place for these springs to fail after many years of use. I've seen these weights embed themselves in the bottom of the clock case when these springs fail. Center arbors on these are held in by this brass locking clip on the back of the movement. Remove the rack so the center arbor will slide out. Oh, I see the hour wheel has been damaged as well. It's going to need to be straightened. Center arbor is bent on both sides of the pinion. It no longer meshes smoothly with the minute wheel teeth. I'll check the run out and see just where the bend starts. The inner shaft is straight. Only a small portion next to the pinion is bent. About 13 thousandths of an inch will need to be corrected. Now to check the runout of the outside section. The bend seems to start right here. First, I'll need to fabricate a couple shaft straightening sleeves. I'm using some soft, round bar stock. Center drill at the center. Lots of oil and slow feed rate, or the drill bit will seize and break. They look great. There's a counterbore on the end that fits the brass shoulder of the pinion. Finished hole is within 1/1000th of an inch of the arbor diameter. Once the arbor is straightened, the counterbore will nest on the brass shoulder for support. The end of the tool without the counterbore will be used for the straightening process. I'll straighten it until the brass shoulder mates up to the face of the sleeve. Once straight, the counterbore will rest over the brass shoulder. The outer straightening sleeve has the same design configuration. Using these sleeves prevents the good part of the arbor from getting any unwanted bends in it. I'll use this heavy cast iron V-block for support during the straightening process. Straighten this end that's snugged in the V-block first. It needs just a little bit more. Now that the counterbore fits the brass shoulder for support, the other end can be worked on. A small amount more, and it should work okay. This looks good. Now the hour wheel. The snail will need to be removed to do the straightening. One of the arms is bent. I'll check the runout of the pipe. Shows no damage, less than 1/1000th of an inch of runout. Our wheel gear shows it's quite far out. Use a smooth-jawed tool so no tool marks are left. Looking better. Check to see if the teeth mesh with each other. They look great. Now, what can be done about these torsion springs? They're a fairly complicated spring to fabricate. Multiple key dimensions that need to be exact for them to operate correctly. I'll need to make some tooling for these as well. These torsion springs were used a lot in the early 1900s. The lock wires are mild steel and are easily removed. A brass thrust washer, here's the setup used for winding the spring. Because piano wire is used for these springs, the mandrel needs to be calculated slightly smaller than the finished size needed. Once the spring is wound, it needs to spring back to the size needed. There's a formula that needs to be used to get the correct size of mandrel. I used a drill bit for this mandrel. I'll do the winding by hand since only 2 springs are needed. The carriage on the lathe needs to be advanced slightly as it's wound. Not too much because the coils need to contact each other on a torsion spring. It's important to have constant tension on the spring wire during the winding process. I wind about twice the amount needed to allow for trimming and final bending process. This one is ready to cut loose, so I'll back off the tool holder. I'll leave extra wire on the spring and also enough sticking out of the tool holder to start the next spring. The orange flash of light seen when it's cut is the release of potential energy of the high-tension piano wire under stress. The setup is temporary, since these are a one-time build. A spool of piano wire, 3 pieces of 5/8 6061 aluminum mounted in the tool rest. The one piece of aluminum clamped on the piano wire has a small groove milled in it, slightly smaller than the diameter of the wire. It fits snug on the wire and provides the tension during the winding process. I may not see another spring job like this for several years, so no need to spend too much time on fancy tooling. Another critical step is the shaping of the spring hole that nests to the fastening screw. It needs to be exact for correct fit-up. I made this temporary bending jig. It has the exact centers of the winding arbor to the fastener center, along with correct diameters. I used slightly undersized drill bits for the mandrels. Once the first bend is made, to form the fastener loop, the spring is reversed to complete the loop. Using a smooth jawed vice grip, the wire is wrapped around itself to complete the bend. The bending tool is made from a piece of leftover 6061 5/8 aluminum. Works nice for a temporary bending tool. Using standard drill bits prevents the need to machine the pins and mandrels. The springs should be a perfect fit-up after they're trimmed to length. The original spring has a square cut end. I used a closed ground end. They look much better with the ground ends on them. They need to be wound in reverse to install. Excellent. The fastener hole is located right in the center. A nice smooth action with a positive lock. The lock wire on these is a soft wire. When winding the clock, the torsion wire loosens on the arbor and slides like a clutch. When released, the wire snugs up around the arbor and locks the weight in place. One spring is a right-hand wind and the other is a left-hand wind. These worked out just great. Just a slight pressure on the center arbor, and the escape wheel and pallets work smoothly. It's going to be a good running clock once the owner cleans and lubricates it. What we believe to be an early Dufa grandfather clock movement. Dufa clocks of this vintage would have had a label similar to this one fixed to the case.